So equivalent system, in this equivalent system, you can see in this figure that there are two traffic lights having weights W1 and W2, and they are having a distance D1 and D2 from their support at O. So we can replace these multiple forces by a single force, and moment produced by these two forces by a single moment, which can be represented at its support. So this is called a equivalent system, and in this way it is simplified and easy to solve and understand. So uh, you can see in this the second figure that we have sum up these two forces and represented it as WR, and we have uh, calculated the moment, resultant moment due to these two forces, and represented is as MRO. It means the resultant moment at point O. We will show these resultant force and resultant moment at the support. So we will uh, now solve this example to understand the concept of force coupled system. In this figure, he is asking you replace the force and couple system shown in figure by an equivalent resultant force and couple moment acting at point O. You can see in this figure that there are three forces acting on this body. This body is fixed at point O, and he is asking you to replace all these forces by a resultant force and resultant couple. So now we will solve this example by first, in the first step we will resolve the forces. Sum of forces along x-axis, we take sum of forces along x-axis, and in the second step we will find out sum of forces in y-axis, and then we will find the resultant force, which is equal to fx square plus fy square under root, and then we will find the resultant moment about point O. So first we will see at the forces. This is the x component of this force. This is x, which is equal to 3 cos 30, and this is the y component of this force, which is equal to 3 sin 30. Then we resolve this force into its x and y components. This is x. X is 5. At angle is not given, but we can find the angle with this small triangle. We know cos theta is equal to base. This is base. This is perpendicular. So cos theta is equal to base over perpendicular 3 by 5. And the second component is y component, and y is 5 sin theta. Sin theta is always equal to perpendicular over hypotenuse. Perpendicular is 4 by 5. So The third force is in the y direction, and the coordinates are given in this figure. You can see here, this is x, so x is positive on the right side and y is positive on the upside. So now we have resolved the forces. Now we write it here. First one is 3 cos 30 plus 5 3 by 5. Then we sum up these two forces to find the sum of forces in x direction, which is equal to 5.598 kilonewton. In the second step, we'll sum up the forces in y direction. So first one is 3 sine 30. The second one is negative, because it is downward, negative 4. The second one is also negative, so it is negative 5 multiplied by 4 by 5, and the result is negative 6.5 kilonewton. So now we have found the x and y components of we have summed up x and y components. Now we'll find the resultant. So fx is equal to 5.598 square plus negative 6.5 square under root, and the answer is 8.58. We can also find the angle theta, which is equal to tan inverse, negative 6.5 divided by 5.598, which is equal to 49.3, which is with the negative sign. Now we'll calculate the moments. We'll see that each component of force has a perpendicular distance from point O. Then we'll see that this component of force 3 cos 30 has a perpendicular distance 0.1. So it will rotate the body in anti-clockwise direction. So we'll write it here, 3 cos 30 multiplied by 0.1. The second component of this force will try to rotate in anti-clockwise direction, and it has a distance of 0.2 meter. This distance is 0.2 meter. So plus 0.2 multiplied by 3 sine 30. Then we'll come to this force, and it has a perpendicular distance of 0.1, and it will rotate the body in anti-clockwise direction. So plus 5 into 3 by 5 multiplied by 0.1. The second component of this force will try to rotate in clockwise direction, and it has a perpendicular distance of 0.3 plus 0.2, which is equal to 0.5. So we'll place a negative sign. 5 into 4 by 5 multiplied by 0.5. The last force is of 4 kilonewton, which will rotate the body in clockwise direction in this direction, and it has a distance of 0.2 meter. So it is with the negative sign, 4 multiplied by 0.2, and then we will find the answer, which is equal to negative 2.46 kilonewton meter.